A very good evening, everyone, and welcome to Adson Engineering Academy. It is me, your tutor Adson, and we're still continuing on our lecture series on the topic principal stresses and strain. And today I'm going to take you through problem number 3, and it's a combination of the direct stresses and the shear stresses, as you can see from the particular diagram. So without wasting much of time, allow me to take you through this particular problem that we're going to do. The question says, in a 2D solid body below, this is the 2D solid body, you are asked to determine the normal and shear stress on the inclined plane PQ. That is our first part. Then the second part is direction and magnitude of the principal stresses. Then the last part is magnitude of the greatest shear stress. Now, as you can see from what we have here, we have a direct stress, sigma y is 40. And it is away from the member, that means it is what? It is tensile. Then sigma x is 75, away from the member, also that means it is what? Tensile, and all of them are taken as positive. So if you look into this, we have the shear stress given that tau xy is the same as tau yx, and it is what? 60. Now the first question says we have to find the normal and the shear stress on the inclined plane PQ. In my first introduction video, I gave you the formulas that you have to use to find the normal and the shear stress. That was particular case 4. So you need to watch that first video so that you get the concept clearly. Now let's solve the first problem, that is normal stress on the inclined plane PQ. So what is the formula of finding this normal stress? We found that if I want to get sigma normal for this case 4, I use the formula sigma x, then plus sigma y by 2, then plus sigma x minus sigma y by 2, and this one is cos of 2 theta plus tau sine of 2 theta. This was the formula we had to calculate sigma what? Normal for this particular case. So let's substitute, and what shall we get? So this is sigma x and the value is 75 plus sigma y, the value is 40 by 2 plus sigma x, the value is 75 minus sigma y, the value is 40 by 2 cos of 2 times theta. And what is our theta? In this case, the theta is the inclined angle, the oblique angle, ready to the vertical. So we just take it as 32. Okay? Well, plus tau, and tau in this case is taken as this one, which is 60, sine of 2 times 32. Okay? So this is how easy it is. We just have to feed this into our calculator. And if you feed it correctly, you're supposed to get 119.1 Newton per millimeter square. Well, so this is our first part, which is the normal. We have to do also for the what? The shear stress. Okay. So what is the formula for the shear stress? We found that sigma t is given by the formula sigma x minus sigma y by 2 sine of 2 theta, then minus, remember this one was plus, then for sigma t is minus tau cos of 2 theta. So sigma t is going to be equals to, what is sigma x? 75 minus 40 by 2 sine of 2 times 32 minus 60, which is tau cos of 2 times 32. Okay? Yes. So this answer is coming to negative, which is 10.57. Okay? Why am I not writing negative? It's because it just shows that it is acting on the other side of the plane. Okay? Yes. Now you can write here negative, or no need to write it. So you find that it's not in the same quadrant the way the sigma n sigma normal lies. They're in different quadrants. So part A is done. Let us go and do the second part too. So B part of the question, we asked to find the direction and the magnitude of the principal stresses. I gave you what we call the major principal stress and then the minor principal stress. That is what the question is asking. Then the direction. Okay. So we start with getting the sigma major. Sigma major, we found that the formula is sigma x plus sigma y by 2. And then plus, because it is sigma major, root of sigma x minus sigma y by 2, all of this squared, and then plus tau square. This was the formula for sigma major. To get the one for sigma minor, you just change this plus to minus. Okay? Yes. So let's get sigma major. In this case, is going to be equals to sigma x is 75 plus 40 by 2, then plus root of sigma x is 75 minus 40 by 2 square. Okay? And then plus 60 square. So the answer is positive 120 Newton per millimeter square. Okay? Yes. Now we have to do for sigma minor. Okay? Sigma minor. You just have to change this to minus. So for sigma minor, this formula changes here to minus. Okay? So the answer is therefore going to be sigma minor equals to, this is 75 plus sigma y is 40 by 2 minus here root of, this is 75 minus 40 by 2 square plus 60 square. Okay? Yes. Now you realize that if you feed this into your calculator, the value of sigma minor is coming to negative 5 Newton per millimeter square. Okay? So we're done with getting the magnitude. Now we have to find the direction. Okay? In our previous video also we learned that the direction that is given by tan of 2 theta p, okay, is equals to 2 tau out of sigma x minus sigma y. In this case, I will have tan of 2 theta 2 p to be equals to 2 times the value of tau that we know is 60 out of 75 minus 40. Okay? Yes. So if I take tan the other side, this side will remain 2 theta p equals to arctan of 120 out of 75 minus 40 is 35, right? So what is the value of 2 theta p? Equals to 73.7 degrees. Because I have 2 here, I have to read the next angle that come after this. Just add 180 to this, 73.7. This is trigonometry. So what will you get? If you add 180 to this, it's coming to 253. 253.7 degrees. Okay? But I don't want 2 theta p. I want only theta p. Theta p is going to be, you have to divide this by 2 and also divide this by what? By 2. So you get 36.9 in terms of degrees. And if you divide this by 2, it's 126. Okay? 126 0.9 degrees. So as we found from the previous video, you find that one is lying in this quadrant and the other one is lying in the other quadrant. We have two what? Two angles. Okay? Yes. So we're done with B part of it. We are now left with C part of the question, which is magnitude of the greatest shear stress. Well, C part, the question is asking to find magnitude of the greatest shear stress, that is tau max, and the formula is half root of sigma y minus sigma x. Take note of this. Then plus 4 tau square. Take note of the formula. Okay? Yeah, you can pull this 4 out. If you wish, then that means the denominator here will be 2. So let's substitute here to get this tau max. This is going to be half root of, what is sigma x and sigma y is 40 minus 75. Everything is squared. Remember, if it's a practice, it's negative, but if you square, the negative disappears. So there's no problem with that. Then plus 4 times, this is only, 4 is not squared, it's on the tau which is squared. So this is going to be 60 squared. Okay? Well, so the answer of this, if you feed this correctly into your calculator, you have to get 62.5 in Newton per meter square. The question was only asking us to get the magnitude of the greatest shear stress. The question did not continue to tell us to get the plane or the direction in which it is inclined. Okay? So that means for now we're going to stop here, and in my next video I will explain to you in details how to find also as far as the direction in which the greatest shear stress can also be inclined. Okay? So please do revise the first video, watch the second video and get to this one. Then I'll elaborate more in the next video how to solve some more other problems on this topic. Thanks so much for watching this video till the end. It is still Adson Engineering Academy. Please like the video, subscribe to this channel so that you don't miss any of my video, share with your friends too.